a fun guy. Obviously, I love the game of
chemistry.
I mean, it's just more questions you have to ask me in order for me to tell you about myself. I just can't give you a whole spiel. I don't even know where you're sitting at.
Turn it up in the headphones. Yeah. Is this good? Do I look good?
Yeah.
It's chemistry.
Talking about energy and bond association. High potential energy, the more the separation takes energy to break a bond, releases when it's formed. There's a lot you can do, man, it just goes on. Bonds broken, minus bonds formed, gives you some traction. Enthalpy of reaction in kg. Now we're talking, now we're in action. Positive, it's endothermic, negative, it's exothermic. Negative could mean it could be spontaneous, but we need to see. Gives free energy to see what the relation is. Take it to the equation, enthalpy minus entropy multiplied by Kelvin T. Now temperature, we got a lot to say around it. If it goes up, it could be spontaneous. Even with positive, enthalpy means it's driven by entropy, because increases gives negativity. Does this in two ways. Increased kinetic energy increases probability of hitting activation energy and things with the right orientation about it. Astounded. Now if it's off, directionality is flawed, the reaction won't go on. I bet y'all really like this song.
If we increase concentration, more particles will collide. If they have the right orientation, the reaction shifts to the right side.
Acids and bases, let's get back to basics.
pKa go up, the stronger the base is.
Weaker the acid, it might stay attached with.
A proton don't donate, it keeps it on its plate.
Ain't lying, no mistake, but stronger than the base.
And H plus it will take, it's selfish, I will say.
Determine the strength of an acid, it's easy.
Just go back and check, go look up at your Serhi.
Check the conjugate base of the acid
to see how well the leaving group it can manage.
S is for size and it's really no surprise.
The bigger an atom, the more it's polarized.
Can't hold up a bond, so it gives off the H plus.
In water, that means hydronium, it goes up.
The new base is more stable, so this EQ is favored. Move on to EM, boy that's my player. Look at the top right of the periodic table. Those conjugates, they gon' be so much more stable. Resonance plays a role too, my dude, don't forget it. More of the structures, less protons you're getting, you get it. Move on to hybridization. More S character, get more nuclear penetration. The closer that they are, that's more of an attraction. Harder to fracture, no ready, set, action. We're back in inductions, last thing that we gon' talk about. Atoms away from the proton, no doubt. E and atoms move the electrons right out of the electron cloud, and it kicks the plus out. Now in summary, conjugate base stability leads to low free energy, 202 at Emory.